If we have a following heat problem, derivative of u with respect to 2 equals to second derivative of u with respect to x and x plus e to the negative x, when x is between 0 and pi, t is positive, and we have boundary condition u of 0t equals to u of pi, t equals to 0, and we have initial condition u of x 0 equals to sine of 2x. So we want to solve it. The way we're going to solve it is we're going to write u as a sum of two functions, v of x, which is steady state solution, plus w of xt. Now, to find v of x, we're going to get derivative of v with respect to t equals to 0, derivative of v with respect to x, so it will be just the regular second derivative of v, plus e to a negative x. And also we have initial conditions on v of 0 and v of pi equals to 0. So from here we can get second derivative of v equals e to a negative x. So first derivative of v equals second derivative of v equals to negative e to a negative x. So first derivative equals e to a negative x over negative 1 plus c1, which equals to e to a negative x plus c1, and v equals negative e to a negative x plus c1x plus c2. Now we're going to use the initial conditions on v to solve for c1 and c2. So v of 0 equals to 0 implies 0 equals negative 1 plus 0 plus c2, so c2 equals to 1. Now we're going to use the second initial condition, v of pi equals to 0. So v of pi equals to 0 implies 0 equals negative e to a negative pi plus c1 pi, c2 equals to 1 plus 1, c1 pi equals e to a negative pi minus 1, so c1 equals e to a negative pi minus 1 over pi. So now we found our steady state solution. So we get negative e to a negative x plus c1, which is e to a negative pi minus 1 over pi, times x plus c2, which is equals to 1. Now we'll try to find transient solution, w of xt. W of xt is going to have conditions derivative of w with respect to t equals to second derivative with respect to x. Boundary condition on transient solution, w is going to be w of pi t and w of 0 t equals to 0. And initial condition is going to be our original addition condition minus v of x. So we're going to get sine of 2x plus e to the negative x plus 1 minus e to the negative pi over pi minus 1. And that is homogeneous regular heat equation. We know how a solution is going to look like. So w of xt is going to be equal to, and from 1 to infinity, cn e to the negative n squared t sine nx, where cn equals to 2 over pi integral 0 to pi minus e to a negative pi over pi x minus 1 sine of n x dx. For now, we're going to concentrate on calculating integral 0 to pi e to a negative x plus 1 minus e to a negative pi over pi x minus 1 times sine of nx dx, which is this part of our integral when we calculate Cn. We're going to break that integral into three pieces. Integral 0 to pi e to a negative x sine nx dx. Integral 0 to pi 1 minus e to a negative pi over pi x sine of nx dx. And the last one is going to be integral of, let's put minus in front, 0 to pi sine nx dx. I'll start with the easiest one, second one. So we're going to get negative cosine of nx over n from 0 to pi. So minus minus give us plus. So we're going to get cosine of pi n minus 1 over n. And instead of saying cosine of pi n, we're going to write down negative 1 to n minus 1. Now to calculate the second integral, I'll take 1 minus e to a negative pi over pi out. I'm going to get integral 0 to pi x sine nx dx. I'll do integration by parts. So x, derivative of x is 1. Sine nx, antiderivative sine of nx is negative cosine nx over n. So we're going to get negative x cosine nx over n plus integral cosine of nx over n dx. Don't forget to multiply it by 1 minus e to a negative pi over pi, and we do it from 0 to pi. Negative x cosine nx over n plus sine nx over n squared. We're going to do it from 0 to pi, and we're going to multiply it by 1 minus e to a negative pi over pi. When we substitute in pi for sine or 0 for pi for x or 0 for x into a sine x, we're going to get 0. So that term will be gone. If we substitute in 0 for x, we're going to get 0. So the only thing which will be left here is going to be negative pi cosine of pi n over n multiplied by 1 minus e to a negative pi over pi. Pi and pi will be cancelled out. So we're going to get negative 1 to n, 1 minus e to a negative pi. And we're going to rewrite it as negative 1 to n plus 1 times 1 minus e to a negative pi over n. Now to calculate the second integral, we'll be using the formula, so that value of that integral equals to e to a negative x over n squared plus 1 times negative sine nx minus n cosine of nx, and we do it from 0 to pi. So we're going to get, if we substitute going to keep n squared plus 1 for whole denominator. If substitute pi, we're going to get e to a negative pi times sine of pi n equals to 0, so times negative n. Cosine of pi n, we're going to write down negative 1 to n. Now if we substitute 0 for x, we're going to get e to the 0 is 1, sine of 0 is 0, so we're going to get plus n. So we'll reduce that expression slightly, and I'm going to be writing e to a negative pi n minus negative 1 to n will be negative 1 to n plus 1. So finally, we get value of our integral equals this expression plus this expression plus this one. So it's going to be consistent of these three pieces. Now we are ready to write down our solution. So u of xt equals v of x plus w of xt, where v of x equals negative e to a negative x plus e to a negative pi minus 1 over pi x plus 1, and w of xt equals sum n from 1 to infinity cn e to a negative n squared t sine of nx, where now let's figure out what cn equals to. If n is not equals to 2, then sine of 2x multiplied by sine of nx, when we do integral from 0 to pi, that should be equal to 0, because sine of 2x is going to affect only c2 coefficient. So cn is going to be equal to value of the integral which we found out times 2 over pi over n plus negative 1 to n minus 1 over n. That is when n is not equal to 2, and when n equals to 2, if we want to calculate c2, that sine of 2x going to affect it, so we're going to put extra 1 plus value of that integral when n equals to 2, and value of that integral when n equals to 2 equal the value of that integral when n equals to 2 equals 2. So copy that 2 over pi, and value of integral 2 squared plus 1 is 5, e to a negative pi 2 times e negative 1 to 3, so we're going to get minus times 2 plus 2 plus we're going to get negative 1 to the third, we're going to get 2 here, we're going to get minus 1 minus e to a negative pi, and minus 1 squared is 1, 1 minus 1 is 0. And that's going to be our solution to this